of relativity is the base of our modern classical physics. In previous episode, I briefly discussed the history of relativity and reference frame. In this episode, we will discuss few more examples on classical relativity and limitations of Newton's law. The most interesting and extraordinary theory called Einstein's theory of relativity. And let us understand how physics telling that time can slow and fast with speed of an object, and we can go to our future without spending time. And the first reality of time machine. Before watching my video, please see all the before episodes for a better understanding. Let's start my video. Please subscribe, like, and share my video. Your support will be my inspiration. Aristotle, a great philosopher and astronomer, born in 384 BC in ancient Greek. Over 2,300 years ago, Aristotle made major contributions to science and philosophy, who believed in an earth-centered universe, and this theory continued till 16th century. Then, in 16th century, Italian physicist Galileo Galilee moved beyond Aristotle's philosophy to introduce the modern study of mechanics for measurements of bodies moving in space and time. His work and that of others led to basic concepts such as velocity, which is the distance a body covers in a given direction per unit time, acceleration, the rate of change of velocity, mass, the amount of material in a body, and force, a push or pull on a body. And the most importantly, he discovered a new theory called relativity, which changed the scientific conception of the universe, which began in efforts to grasp the dynamic behavior of matter. In the late 17th century, when the British scientific genius Isaac Newton formulated his three famous laws of motion, the first and second of which are of special concern in relativity. Newton's first law, known as the law of inertia, states that a body that is not acted upon by external forces undergoes no acceleration. Either it remains at rest or continuing to move in a straight line at constant speed. Newton also defines space and time, taking both to be absolutes that unaffected by anything external. He wrote, "Time flows equably, or we can say time is equal in everywhere, while space remains always similar and immovable." And his most extraordinary discovery of force of nature, which was gravity. And this name was given because in Latin, gravis means heavy. So Newton gave the force name gravity. He gave a simple mathematical expression for the gravitational force. It states that every object in the universe attracts every other object with a force that operates through empty space, and that varies with the masses of the objects and the distance between them. The law of gravity successfully explained the mechanism behind Kepler's laws of planetary motion, which the German astronomer Johannes Kepler had formulated at the beginning of the 17th century. Newton's mechanics and law of gravity and his assumptions about the nature of space and time seemed wholly successful in explaining the dynamics of the universe, from motion on Earth to cosmic events. But in 18th century, another weird thing discovered, that was nature of light, which make all in a puzzle. Then there was an entry of another brilliant mind, the most intelligent and genius person in 18th century. He was James Clerk Maxwell, a Scottish scientist in the field of mathematical physics, and who was founder of the modern electrical engineering. His most notable achievement was to formulate the classical theory of electromagnetic radiation. he brings together for the first time electricity, magnetism, and light as different manifestations of the same phenomena. Electromagnetic radiation, which is a wave of electric fields radiating through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. He gave an equation called Maxwell's equation, which predicted that electromagnetic waves would travel through empty space at a speed of almost exactly 3 × 10⁸ meters per second at any frame of reference, and it also experimentally proved. But there was another fundamental issue. If light is a moving wave, what medium support it takes? Because ocean waves and sound waves consist of the progressive oscillatory motion of molecules of water and of atmospheric gases respectively. But what is it that vibrates to make a moving light wave? Or to put it another way, how does the energy embodied in light travel from point to point? Wow! And to solve it, a hypothetical medium called the ether got birth. But 1887, the German-born American physicist A. Michelson and the American physicist Edward Morley made precise measurements to determine how Earth's motion through the ether affected the measured speed of light. Because Earth's movement would add to or subtract from the measured speed of light waves, just as the speed of a ship would add to or subtract from the speed of ocean waves as measured from the ship. But when Michelson Morley experimented this, they found an unexpected outcome. For the measured speed of light remained the same regardless of Earth's motion. It means that the ether had no existence, and finally, why light moves and wave became unsolved. So in early 19th centuries became so confused to understand the nature. One side Galilean's relativity, another side Newton's view about time and gravity, and Maxwell's discovery of electromagnetism and light is a wave, and another side discovery of steam engine with train running with different time according to their sun position. But every dark have a light side also. Do you know one thing? Anything you see, feel, or realize in the universe is not same or real. But any weird you can think is the reality of this universe. It is experimented and found in quantum physics. This is the only truth in this universe. I am enough of an artist to draw freely, open my imagination. Because imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. A famous quote of intelligent mind. He was Albert Einstein, the most intelligent person on 19th century. In year 1905, he published 4 articles, contributed substantially to the foundation of modern physics, and changed views on space, time, mass, and energy. The first paper was the theory of photoelectric effect, for which he got Nobel Prize. The second paper explained Brownian motion. The third paper introduced special relativity, and the fourth is mass-energy equivalence. And together, these papers made the 4 pillars of modern classical physics. But among them, the most interesting and weird theory, or the secret of nature, is special relativity. The theory of special relativity explains how space and time are linked for objects that are moving at a constant speed. It is based on two postulates. Number one, the laws of physics are identical in all inertial frames of reference, or non-accelerating frames of reference. Number two, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source or observer. Einstein described how at the age of 16 he watched himself in his mind's eye as he rode on a light wave and gazed at another light wave moving parallel to his. According to classical physics, Einstein should have seen the second light wave moving at a relative speed of 0. But according to Maxwell's electromagnetic equations, light always moves at a speed of 3 × 10⁸ meters per second. Nothing in the theory allows a light wave to have a speed of 0. Another problem arose as well. If a fixed observer sees light as having a speed of 3 × 10⁸ meters per second, whereas an observer moving at the speed of light also will see the light moving at speed of 3 × 10⁸ meters per second, how it will be possible? In order to make the speed of light constant, Einstein replaced absolute space and time with new definitions that time can slow down according to the speed of the object, which became the first theoretical proof to make a time machine. To explain it, Einstein gave birth of a new theory called special relativity. The theory of special relativity explains how space and time are linked for objects that are moving at a constant speed in a straight line. Time flows differently according to the state of motion. That means when a body moves in space at constant speed, its time becomes slow. The faster a body will move, the slower the time will pass. Or flow of time is not equal for every motion body. Or we can say every body have their private time, which outcomes theory of relativity is just to challenge Newton's laws of motion and time is same at any corner of the universe. Wow! Theoretical fighting between the two great scientists. Let us understand special relativity taking an example. Suppose a train moving at a speed of half of the speed of light, firing a light beam to a target point, and from same starting point, a person at rest fire a laser beam to the same target point. In both the case, the speed of light will be same. To achieve the same light speed in both reference frames, one has to slow down, and that to be the time, because speed equals distance by time, and the distance is same. To keep the speed of light same, time have to slow down. That was the simple postulates of Einstein's special relativity, which is further called time dilation. To see few more examples of special relativity and its consequences like length contraction, relativistic mass, mass-energy equivalence, a universal speed limit, the speed of causality, which has been experimentally verified. Please see my upcoming video, Special Relativity Part 2. Till now, thanks for watching my video.